Okay, 4.1, modeling with quadratic relations. So we're going to review from last year what a parabola is. So parabola is a symmetrical U-shaped curve. Okay, so this is either basically a happy face, okay, a smile, or a frown, sad face. Okay, this shape is the graph of a quadratic relation. And as a reminder, quadratic relation is in the form y equals x squared. Okay, it's this exponent 2. Now, a vertex is the lowest or the highest point on this parabola. So on this parabola that opens up, this would be the vertex, and the parabola that opens down, this right here would be the vertex. Okay, and because we open up, we have a minimum. Okay, this is the y coordinate because you're going to have some x and some y. Okay, this is the y coordinate, that's the lowest coordinate on the entire graph. But we're going to have a maximum when, again, if we have some x and some y axis, and we're opening down, we're going to have some y coordinate right here, where this point, the vertex, is the highest point on the parabola. Okay, but these go together. If it opens up, it's going to have a minimum, the lowest point. If it opens down, it's going to have a maximum, the highest point. Okay, those are interchangeable. So let's start on the examples. Example 1, the following table shows a soccer ball's height h. Okay, this is height in meters above the ground over t seconds. So this is time after it was kicked in the air. Graph the data, draw a smooth curve through the points. Okay, so this time we're going to transition to scatter plots. Okay, so first of all, let's label the t and the h axes. So this is time, and this is going to be in seconds, and then this is going to be height, and it's going to be in meters. Okay, and we can call this path of the soccer ball. Okay, so 0, 0.1. So 0, 0.1 is going to be here. 0.5, 7.8. Okay, 0.5 is going to be halfway between 0 and 1. Okay, and then 7.8. 1, 12 is going to be here. 1.5, okay, which will be halfway between 1 and 2, 13.8. 2, 13, 2.5, 9.75, right here, and 3, 4. Okay, so these are our points, and now we're going to draw a smooth curve through these points. Okay, and eventually that will go down and hit the ground. B asks, describe the shape of the graph. When we talk about this shape specifically for a curve, okay, we're talking about a quadratic. So the actual shape itself is a parabola. Okay, it's not a square, it's not a circle, it's a parabola. That's a shape. Okay, now what was the ball's maximum height? So here's the thing, we have this curve, it's not completely, like it could have went up a little bit more here and then came down. This is likely what happened because it doesn't fall at 3. So if you remember, a parabola is symmetric. So if it fell at 3, the vertex would occur at 1.5, but it falls just a little bit after 3, not quite 3.5. So our vertex is going to be about right here. Okay, it's going to be halfway between maybe 1.5 and 2, but it's going to be halfway between this ground point here and this ground point here. Okay, so we can call this 14. Okay, so what was the ball's maximum height? 14 meters. Don't forget to put the units because this is applied to an actual word problem. Okay, and for about how many seconds was the ball in the air? So the ball starts to be in the air at 0 seconds, goes all the way up, all the way down. And this, we can call this about 3.25, 3.25, maybe 3.3. Okay. But it's going to be approximate because we don't have a specific equation. So 3.25 seconds. Example 2, determine if the following table of values represents a quadratic equation. So here's a review of first and second differences. Okay, so as long as the x's go up by the same amount, so if we think about it, delta x, which is the change in x, is 1 every single time, okay, between these consecutive points. So because those are all 1, we can use first and second differences. Okay, so how we do that is we go up the y column. So if you need to make a note, say subtract up, not down, okay, the y column. So we have 1 minus 6, which we get -5. We have 6 minus 9, and we get -3. 9 minus 10, we get -1. 10 minus 9, we get 1. 9 minus 6, we get 3. And 6 minus 1, we get 5. Okay, for first differences, this box will not exist. There will not be a value. It'll be one less box. Now with the second differences, we go up the first difference column. So we could say subtract up the first difference column. Okay, so we have -5 minus -3. Don't get caught not doing the double negative here. So we get -2. -3 minus -1, -2. -1 minus 1, -2. 1 minus 3 is -2. And 3 minus 5 is -2. Okay. We already know that there's not going to be a value for that top box, but now it's even one less. So every time you do the next difference, it's one less box because there's no more numbers left to compare or to subtract. So now let's take a look at the trends. So are the first differences the same? No. So we know that this is not linear. Okay, so we say not linear. But are the second differences the same? Yes. Okay, so these are the same, or they're constant. Okay, so quadratic equation. A quadratic equation has constant second differences. Okay, because the second difference is constant, we can say it's quadratic. The equation for a quadratic has an x squared term. Okay, where that 2 for like second difference, that 2, there's your theme. The 2 is going to be the exponent. So example 3, determine whether the following equations represents a quadratic relation. Well, what did we just say that a quadratic relation has in it? Okay, it's going to be in the form y equals x squared. Okay, this may look a little differently. It may be like 2x squared plus x plus 1, but it's still going to have that x squared in it. Okay, it may look like x plus 1, x minus 3. But if we expanded this, x times x, it's still going to have an x squared in it. Okay, and it may look like this, 2x minus 1 squared plus 6. Okay, but this right here, if we expanded this, we know anything squared is going to be it times itself, and x times x is still going to give us x squared. Okay, so any version of an x squared equation, that's a quadratic equation. So let's take a look at these. Okay, for A, we have y equals 2x squared plus 5. We have x squared. Okay, so yes, this is quadratic. Okay, so what about this one? We have y equals 3 to the x. This is not squared. Okay, so this is not quadratic. If we have a variable in the exponent, it is not quadratic. Okay, and now finally C, we have y equals 4x minus 3. You might see that as a line, right? Y equals mx plus b. But if you can't recall that, that's okay still. This x value is to the exponent 1, so not quadratic.